I watched a video last week from Jeremy Make Things. A very well made and interesting video where he makes a vise for his freshly restored shaper. And he wants to do it this way. He has a base plate for his vise and the fixed jaw is held in place with a key. A bit the idea of this little vise. Here is the key that holds the fixed jaw. But he wants to make it on the shaper and in one piece. I think that's a really interesting idea. Make it in one piece. The only downside is, of course, you lose lots of material here, but as a hobbyist, we don't care. Now, his idea was to put the thing, of course, this side up in the shaper, and then you have to cut first with a cutting tool this right shoulder, and then switch tool and cut it with another one to make the other one right shoulder. And the problem is, this height has to be exactly the same. Now, it's perfectly possible, but indeed it's a little bit of a challenge. And then he decided to make it in the middle. Of course, there's absolutely nothing wrong with the idea to make it in the milling machine. I think it's a really good decision. But what if you don't have a milling machine and you have only the shaper? I roughed out both sides with whatever tool, doesn't matter, just rough it out. And I left 1/10 of a millimeter per side. I installed my slotting tool, and if we're gonna feed down only 1/10 of a millimeter, you will see we can get away with it. It's gonna work. The clapper will clap a little bit, but not too much. If you take two big cuts, for example a half millimeter or more, with the flexing of the machine, of course on the backstroke the drag will be more important and the tool will lift more and will scratch here the finished surface. So light cuts. We set the part at 0. Finished dimension on this side of the part. We're not touching this side yet. I will bring you closer while doing this. Never mind these two holes that here in the bottom. Officially they don't exist. I took whatever piece of scrap and I didn't pay attention that there were holes in it. But doesn't matter for the moment. Before we continue, let's check the depth. I don't think it's really far off. I wanted it 4 millimeter. This will do. One side is finished. Let's do the other one. Right, I bring the part back to the 0 point, which is here. I'm gonna move the total width I need here, which is 10 millimeter, plus of course the width of the tool. The tool is 9.65 millimeter. It's marked here, that's why I know it. So let's do this. Now this side of the tool is at the finished dimension of this shoulder. And that's the second reason why we take light cuts, because now we are against the backlash in the machine. Let's cheat a bit. If I take too big cuts, my part will be pushed that way, and the backlash will push it out of position. So that's not a good idea. Let's put it back. Let's hope it's in place now. Let's cut. According to my dial, I'm at the same depth now as the other side. Let's give it a good, quick measurement, hoping that there's not too much burr. That seems okay. Ah. Here we had 399. Come on, Tim. 399. That should do. I'm gonna deburr it and let's have a closer look. 0. We set here 10 millimeters. 200ths of a millimeter over. I don't know you, but I can live with that. The depth. That's a little bit more sketchy to measure. Two-hundredths under, so not deep enough. Turn it around. One-hundredths. I think that will do. In a previous video I showed a bit the possibilities I have using the tackle milling machine. So you can move the table in whatever angle you want, or almost. And a lot of you pointed out that now I have to tram the mill again. And that's not really a problem. I will show you how easy it is to tram the mill here on the tackle. In another video You saw me take very light cuts, maximum 1 millimeter deep. And in the comments there were also people saying that, "Oi, 1 millimeter, that's really not much." I compared the milling machine and the shaper. Cutting time, yeah, okay, if you remember. So we're gonna have a look at what can this machine do. But I also received stickers from Dylan, and Dylan, as you can see, your sticker is already on the cheap door. Go and have a look at Dylan's channel, as always, link in the description of course, and he's restoring an old sawmill, you know, to make big round trees into smaller rectangular pieces of tree. I think that's a really fantastic project, and I really enjoy watching and follow the follow-up of this project. Let's tackle. After the little show-off video I made, of course I trimmed the mill again, but now, as you can see, it's back out of tram. If you have a dial indicator, that's all you need. We don't need all these special T-hole systems with 2 dial indicators, because we have the drilling system quill. Yeah? We can use this to indicate on. I locked the table again in whatever position is not important. The head is held on with 4 bolts. I have here my Allen key, 2 on the top, 2 on the bottom. The 2 bottoms are completely loose and those on the top are just nipped. I set here on the dial the angle at 0, and that brings us really close. I hope you can see the indicator. So after a full sweep we are about 1/20th of a millimeter off of 5/100ths. And if I go back up, it's there where you see the problem I have with this machine. You see, the gibs of this machine are completely cooked. But the person who sold me this, he told me that there was a problem with the gibs and the bearings here in the quill, so I think it's still a fair deal. 1/20th, we said. I'm gonna try to find the zero again. The indicator is moving up, which means this part is closer to the indicator than this part. So we have to move it about half that way. I will do this with my plastic hammer. It's too tight. Something like this. Tight again. Have to move a little bit more. This is it. No movement anymore. As long as I can't fix the gibs problem. I don't think I will get it any better. But for what I do for the moment, this will do. Now that the quill is in line with the, I always forget, with the y-axis, the table is of course not square yet with the y-axis. So let's do that now. First I will set more or less at 0. Now I can see on the indicator that there's 20 hundredths of a millimeter higher in the total movement. What I'm going to do, I start the machine, put the table feed on and try to tram it while running. And whatever the indicator marks, it's not important. The most important is that it doesn't move while the table is feeding. I will bring you closer. Let's speed it a bit faster, will be easier to see. I think I can live with that. I'll tighten the ball. Now that we're in the middle of boring video making, I can as well continue. If I want to trim the tool head of the shaper back at 90 degrees. It's about the same story, but I can't use the automatic down feed, of course, because there is no. What I do, I install an indicator on the side of the table. If you're not sure that the side of the table of your shaper is square, but in fact not really square, but it has to be in line with the y-axis, of course, install indicator this way on the side of the table, move the table up, and after a good sweep you can see if the indicator moved or not. Here it didn't, so my table is square. To check if the tool head is in line, just bring your tool head down, make a sweep, and you have a readout, right? It's easy to regulate this thing. Now, on this machine, it's a little bit more complicated, because here is 1/10 of a millimeter play in the Gibbs. If the sides of your shaper table for whatever reason are not square, or maybe there's paint on it or whatever, you can very easily put a square with a clamp on the table. Not in the vise, of course, otherwise you could make a little error with the vise square on the table and then sweep the indicator on the side of the square. But not this square, but it's not a good one. Of course, I know that most of you know all these things, how to tramming a middle, how easy or difficult it can be, the tricks and little tips. Most of you know it. But if this video can help even only one person, I think it's worth making it. Now let's talk depth of cut this machine, right? When we have a look at the head of this machine, this is a small dovetail. This length is about 300 millimeter, let's say 1 foot, okay? It's a small machine. I never tried, but I'm not sure we can take 10 millimeter deep cuts with it. If I compare with the shaper that you can just see a little part of it here, the shaper is a bigger machine than the milling machine. Let's do it anyway. This is the same part I used in my other video where you talked about depth of cut. It's a 10 millimeter wide soft steel piece of angle iron. This one is a almost 16 millimeter cutter. I installed it in the middle of the part, so we're not client milling and we're not conventional milling, but just milling. I set my depth of cut at 2 millimeter. Let's see what happens. Set again 2 millimeter. So when we arrive here, it will be 4 millimeter. Let's see if it works. Before I continue, I will set the camera on a tripod because I see you guys are shaking around and I suppose you can see nothing at all. I hope this will be a little bit better. Starts to look a bit like an earthquake here. Depth of cut again 2 millimeter, which means when we come over there it will be 6. Stop doing it because machine is really not happy with it. This cut is 6 millimeters deep and 2 millimeters wide. It seems to work, but I don't think it will take more. So as you could see, making big cuts on this small machine is not really an option. Now I admit that using a 2-flute end mill was maybe not the best choice, but this one is an old one and it's in more or less good shape and I don't want to break my beautiful brand new 4-flute little end mills. After all, this is a small machine shop with, of course, small machines. The milling machine is a small machine, the shaper is a small machine, and also the lathe is a small machine. I know that on video it looks bigger than it really is. Trust me, it's a small machine. If I take 2 millimeter cuts on the lathe, it just doesn't work. And now that I think of it, in fact this is a Make Things channel and in this video I didn't make a thing yet. Let's make something. A point. I just made a point.